Welcome to Astronomy Daily, the podcast where we dive into the latest wonders of space and astronomy while drinking coffee. I'm Anna, and joining me is my co-host Avery. Hey Avery, it's January 6th, 2026. I trust the new year is still treating you well?
Hey Anna, and hello to everyone listening. It's been great. Lots of clear skies for stargazing lately. 2026 is already delivering some intriguing stories, from satellite mishaps to upcoming launches and big questions about life in the universe. We've got 6 solid ones today, so let's not waste any time and get started.
First up, a bit of bad luck for a brand new satellite. Spain's newest communications bird, Spainsat NG2, got hit by a space particle while heading to its final orbit.
Yeah, this one's operated by Hisdesat for Spain's Ministry of Defence, built by Airbus as part of a €2 billion pair for advanced government comms across Europe. It launched on a Falcon 9 back in October 2025, and the strike happened at around 31,000 miles up, actually higher than its target geostationary spot at 22,000 miles.
The particle impact was reported just a few days ago, on January 2nd. They're calling it a space particle, which could mean anything from a micrometeoroid to a bit of space debris. Damage extent is still unknown, but Hisdesat quickly activated a contingency plan to keep services running for the Defense Ministry and other clients without interruption.
Their team's analyzing data now, and if needed, they'll replace it ASAP. It's a reminder of how risky the space environment is. Even in high orbits, collisions can happen. Glad they had backups in place.
Absolutely. Space is harsh, but redundancy saves the day.
Shifting to launches, we've got a busy week ahead with several missions on the docket. SpaceX is leading the pack with multiple Falcon 9 flights.
Starting January 8th, Starlink Group 6-96 with 29 V2 mini-satellites from Cape Canaveral. Then on the 10th, Group 6-97, another 29 for the same shell. These are boosting the constellation that's already serving millions globally.
And on the 11th, a cool rideshare called Twilight, or Pandora and others, from Vandenberg into sun-synchronous orbit. Highlights include NASA's Pandora mission to observe exoplanet transits in visible and IR for atmospheric clues, plus Kepler's first operational SATs for a laser-linked mesh network, Spire's hyperspectral microwave sounder for better weather data, and some Lemur 2 birds.
Then ISRO kicks off their 2026 on January 12th with a PSLV carrying EOS N1, an Earth observation sat, possibly hyperspectral for defense, and 18 rideshares, including an experimental re-entry capsule.
It's a packed lineup: Starlink expansion, exoplanet science, weather tech, and more. Exciting to see rideshares making space accessible.
Next, some fascinating lab work bolstering one of the leading ideas on how life began on Earth, the RNA World hypothesis.
The hypothesis says RNA, that versatile molecule that can store info like DNA and catalyze reactions like proteins, might have been the first self-replicating life precursor. A team led by Yuta Hirakawa from Toho University mixed RNA building blocks, ribose sugar, phosphates, nucleobases, and borates from seawater and basalt rock.
They heated and dried the mix, mimicking underground aquifers on early Earth. Surprisingly, borates didn't block formation. They stabilized ribose and helped phosphates, allowing RNA to form naturally through the discontinuous synthesis model steps.
This is big because all those ingredients have been found in space. Ribose on asteroid Bennu via OSIRIS-REx. A massive impact 4.3 billion years ago could have delivered them, kickstarting RNA in borate-rich spots just before life's earliest signs.
Implications? Life might have emerged faster than thought, and similar chemistry could happen on Mars, where borates are detected. It's not proof, but strong lab support for RNA as the bridge to life.
Love how this ties astrobiology to origins right here on Earth.
Speaking of the moon, 2026 is shaping up for a private lunar landing rush, with several companies aiming to touch down.
We're seeing multiple commercial missions targeting the surface this year, part of the broader push with NASA's CLPS program and private ventures. Though details vary, expect attempts from players like Intuitive Machines, iSpace, and others, building on recent efforts.
These soft landers and rovers are scouting resources, testing tech, and paving the way for sustained presence. Successes could accelerate the moon economy.
Definitely. 2026 could be a pivotal year for private lunar exploration.
Now, an ambitious proposal to hunt for habitable moons around distant giant exoplanets.
A team including Thomas Winterhalter from ISRO suggests building a kilometric baseline interferometer, mirrors kilometers apart for ultra-high resolution, down to 1 microarcsecond. Paired with the upcoming extremely large telescope's 39-meter mirror, it could spot Earth-sized exomoons out to 652 light-years via astrometric wobbles.
Current methods like transits are tricky for moons around far-out gas giants, where habitable zones might rely on tidal heating, like Europa or Enceladus. This setup could directly image planets and detect moon signals.
Challenges are huge. Costs in billions. Tech development post-2028 ELT. But if it works, we might find the first truly habitable exoworlds powered by internal heat, not just starlight.
Mind-blowing potential for life beyond Earth-like planets.
Finally, China's Chang'e 7 mission is gearing up to probe the moon's South Pole secrets, especially water ice.
The stack includes an orbiter, lander, rover, a hopping probe for tough terrain, and a relay sat. Target: permanently shadowed craters near the pole, where ancient ice could reveal the solar system's volatile history.
Ridgelines there get near constant sunlight for power, while craters trap ice. Objectives: precision landing, resource prospecting, in-situ analysis, key for future bases.
It's Phase 4 of China's lunar program, precursor to Chang'e 8 for utilization tech, like 3D printing, supporting the International Lunar Research Station. Hopping probe is clever for accessing shadowed spots rovers can't.
This could unlock sustainable lunar habitation, water for fuel, air, drinking.
And that's it for today's space and astronomy news. What a diverse episode. Satellite hits, launch previews, origins of life, lunar ambitions, private and national, and exomoon hunts.
The universe keeps surprising us. Thanks for tuning in to Astronomy Daily. We appreciate you joining the conversation.
If you enjoyed this, subscribe and share with a fellow space fan. We'll be back tomorrow with more.
Until then, keep looking up.
Clear skies.
Astronomy.